Let's go back to the rig file. Let's start adding this feature to the car body. The positions of the four corners of the car body are actually the wheel positions. We've already created the locators for the wheels. So let's duplicate these four locators, then rename them. Let's call them suspension pivot. Then we need to group each of these locators to transfer the positional offset values onto the 0 group. Let's create a group. Then rename it. Then let's snap them to the positions of the previous locators. Then put them under their corresponding groups. This way we have four locators, and their own translate, rotate, and scale are all at default values. The positional values are all stored in the 0 group's translate attribute. Next, just like in our previous exercise, let's add this feature to the car body. First, we need to analyze which controller or which group should we apply this operation to. We know that we have a suspension controller above to control the car body's rotation and translation. So we can just apply the control directly to the group above this controller. Let's find this controller. It only has one 0 group above it. We don't want to directly control the 0 group, so let's add a group in between. Since we're constraining it, let's call this group driven. Then use the four locators from earlier to apply a point constraint to the driven group, because our controller is in the same position as the center of gravity. And when we found the center of gravity, it was the center of the four wheels. So we can still use a point constraint here and turn off maintain offset. Let's create the point constraint. This way the position setup is complete. Let's take a look. When I move this locator, the car body will follow the front left locator's movement with a 25% weight. Next, we need to set up its rotation. This is the same as the exercise. We'll find the position of the two middle points and do an aim constraint. Let's duplicate the locator. Let's call it target to indicate it's the locator driving the aim constraint. We'll use the front center position to drive it, and use the side as the up reference object. Of course, we could also do it like the exercise. Use the side locator as the driving object, and the front locator as the reference object. Then duplicate another one for the side locator. For the side, let's call it up, not target, because it's the up reference object. Then we need to put them in their corresponding positions. The front center point is actually the position of the front controller when we were setting up the front back controllers. So we can just snap it over, select the 0 group, select the front controller, snap translation. As for the side center point, we'll use the two left side locators to apply a point constraint to this 0 group. Snap it over. Then delete this point constraint. Okay, next, we'll use the two front center point locators to apply a point constraint to the front center locator we just created. Then, same method, we'll take the two left side locators and apply a point constraint to the side locator we just created. Then let's copy the up locator's name. Select the front center point. Then select the suspension controller's driven group. Apply an aim constraint. Let's check the z-axis is aiming forward, so the aim vector is z. Then the x-axis points to the reference object, so the up vector here is x. Then use object up. Paste the name of our locator. Click apply. This gives us the same effect as in our exercise. Let's take a look. When I move one of the locators, it will have a lifting effect on the entire car body. If I move both locators on the same side, then this entire side will be lifted. Then let's organize these locators. Who should they follow? Let's see, they ultimately control the suspension controller. The suspension controller is parented under the back controller as its child. So these locators will also parent them under the back controller as its children. Keep them at the same level as the suspension controller. This way, when we move the locators, they can properly drive the suspension controller. And if we make any adjustments to the car as a whole, these locator positions will also follow, and they can still control the car body. Okay, after this effect is done, we need to connect these locators to controllers, because only by creating controllers can the animator animate them. Let's temporarily hide the rig and draw a controller. In Create, find CV Curve tool. We'll use linear mode again. Switch to the side view. We'll draw a double arrow here. Then show the rig again. Let's rename this controller. Let's call it Left Front Shock 0001. Then group it. This is our 0 group. The position of this controller doesn't really matter. Because we are going to connect the controller's translate Y to the corresponding locator's translate Y attribute, we are not constraining it. The reason is we only want to use this layer to control the locator. Above this locator, we'll have other layers of operations later, connecting to some other functions. So since we only need to do an attribute connection, its own position isn't that important. Let's move it to a relatively reasonable place and scale it up a bit to see. I think this position is about right. Maybe a little more forward. And don't forget to set its color. Then freeze transformations. This way, the left front shock control is finished. Then let's duplicate one. This is the controller for the right side. The only difference between the right and left is that its translate X is a negative value. We place it on the right side. Then set its color. Then duplicate again. These two are the back controllers. Let's move this one out a bit. Let's set this translate X value for the right controller and change it to a negative value, so the right side's position is symmetrical with the left. And don't forget to rename. Now all 4 of our controllers are created. Let's put them at the same level as those locators, which is under the back controller as its children. Then connect the controllers and locators with an attribute connection. Open the connection editor. We're only connecting translate Y. So let's take a look. When we move translate Y, the car body will have a tilting effect. Using the same method, let's connect the other controllers. Okay, let's check the result. Looks like there are no problems. Of course, we'll see this rod connecting to the wheel isn't linked to the wheel in any way right now. This is a detail we'll add later. Don't worry about it for now, because if we don't have a shot from this angle, we don't need to rig it. Now, let's do the cleanup. We only use translate Y here, so we need to lock and hide all other attributes. Select the 4 controllers. Select all attributes except translate Y, then lock and hide. Next, we can set a limit for the controllers. Let's see. When moving down, the minimum value is roughly -10. And when moving up, let's take a look. What's the max value? I think setting it to 10 is fine. Then let's look at the back controllers. Moving down, let's see. It's about -15. And upwards, let's set it to 10. I think that's about right. We can keep them consistent. Let's make them all 10 for up and down movement. This way, we select the controller, go to limit information, find translate y, and set both positive and negative to 10. This way, let's check. We have our limits. Then let's do the same for the other controllers. This way, our limits are all set. Pick any controller to check. No problem. Because we set the limits, it won't have a situation where it moves extremely high or extremely low. This way, our car body's lifting effect via the 4 corner controllers is complete. Next, we can consider how to make the wheels link up with this car body lifting effect.